The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to review for the Chapter 9 test, which is due no later than 11:59 p.m. tomorrow night. You can take it any time between now and then, but remember, once you open it, the time starts. Also, as you take your test, if you want to keep track of the ones that you missed, and when the test is over, immediately email me the work from the problems you missed. I will see if you can get partial credit. A reminder, do not correct the work. If you do, then I won't even look at it. You need to send me the work that you did that led to the wrong answers so I can see if you did have some part of the process correct. All righty, I got a request for a couple of problems, so we'll start with those. This is from section 9.5, and this is number 16. It says, solve the equation. Let f of x equal the square root of 5x squared minus 44x. For what value or values of x is f of x equal to 3. So basically, we're going to make a substitution. We're going to put 3 in the place of f of x. So then our equation would look like this. 3 equals the square root of the quantity 5x squared minus 44x. Okay. So now we have an equation with one radical, and the radical is already isolated. It's a square root, so we're going to square both sides. On the left side of the equation, we get 9. On the right side of the equation, we get 5x squared minus 44x. Now we have a second degree equation, so we want to put it in standard form. So we'll subtract 9 from both sides of the equation, which gives us 0 equals 5x squared minus 44x minus 9. So I now have a second degree equation in standard form. It is a trinomial. There's no greatest common factor. Let's see, the leading coefficient is not a 1. It's not a perfect square. So I'm going to use factoring by grouping. A is 5, B is negative 44, and C is negative 9. So the product is negative 45 and the sum is negative 44. So the numbers are negative 45 and positive 1. So now I've got 0 equals 5x squared minus 45x plus 1x minus 9. Factoring by grouping, I get 0 equals 5x times x minus 9. So over here, I'm going to have x minus 9 and a plus 1 outside. So 0 equals x minus 9 times 5x plus 1. So x minus 9 equals 0. Adding 9 to both sides, we get x equals 9. 5x plus 1 equals 0. Subtracting 1 from both sides, we get 5x equals negative 1. Divide by 5, we get x equals negative 1/5. All right, let's check our work on those two answers to see if they are correct. So I'm going to copy the original equation, that is this, on the next page. 3 equals the square root of 5x squared minus 44x, and our two solutions, 9 and negative 1/5. X equals 9, x equals negative 1/5. So let's try them and see if they work. All right, if x is 9, we would get this. Whoops, not quite. 5 times 9 squared minus 44 times 9. Let's see. 9 squared is 81. And 80, let's see here, hang on. 81 times 5 is 405. And then 44 times 9 is 396. And 405 minus 396 is 9, and the square root of 9 is 3. So x equals 9, checks. All right, now let's try the negative 1/5. 3 equals the square root of 5 times negative 1/5 squared minus 44 times negative 1/5. 3 equals. Well, let's see. We've got 5. Negative 1/5 squared would be positive 1/25. And then minus 44 times negative 1/5 would be plus 44/5. Okay. But I could take the 5 times 1/25 and reduce it down to 1/5. So I've got 1/5 plus 44/5, which is 45/5, which is 9, and the square root of 9 is 3. So in this case, they both check. Any questions on anything on this page or the previous page before we go on to another problem? All righty. Yeah, let's see here. This is also from section 9.5, number 24. It says, solve the equation, write all proposed solutions. If a solution is extraneous, so indicate. Okay, so if it's extraneous, then that means you come up with it, solving it, but when you check it, it doesn't work. Okay, our equation is this: negative s minus 3 equals 2 times the square root of 12 minus s. All right, so the radical has already been isolated. We could divide both sides by 2, but I think I'm going to hold off on that because I think that's just going to complicate things on the left side for now. So what am I going to do? I'm going to square both sides. So on the left, I'm going to get negative s minus 3 times negative s minus 3, which is going to be s squared plus 3s plus 3s plus 9, which is going to be s squared plus 6x s, plus 9. On the right side of the equation, the 2 is going to get squared, so that's going to be a 4 times, and the square root of 12 minus s squared is 12 minus s. Any questions there so far? All right, so this is going to be what? 48 minus 4s. And bringing that down, 48 minus 4s. This is a second degree equation. My leading coefficient, I want it to be positive. So I'm going to leave it over on the left side. I'm going to subtract 48, and I'm going to add 4s. That's going to give me s squared plus 10s minus, let's see, minus 39 equals 0. Okay. Righty then. Let's see here. This is a second degree equation. It's in standard form. There's no greatest common factor. It's not a perfect square. It does have a leading coefficient of a 1. So hopefully I can pull it apart like this. Let's see, the sum is negative 39, and oh, wait a minute, that's not right. That's not right. The product is negative 39, and the sum is 10. How about 13 and negative 3? So plus 13 minus 3. So then we've got s plus 13 equals 0. Subtract 13 from both sides, s equals negative 13. S minus 3 equals 0. Add 3 to both sides, s equals 3. So we've got these two possible solutions. Once again, I'm going to recopy the original equation on the next page and then go from there. So we've got negative s minus 3 equals 2 times the square root of 12 minus s. And our two solutions were negative 13 and 3. S equals negative 13, S equals 3. So let's check them. Minus S. All right, if S is negative 13, I get negative times negative 13 minus 3 equals 2 times the square root of 12 minus negative 13. The opposite of negative 13 or subtracting a negative is like adding a positive. So 13 minus 3 or 10 equals 2 times the square root of 12 minus negative 13 would be 12 plus positive 13 would be 25. And the square root of 25 is 5. So we get 10 equals 10. So negative 13 works. Let's take S as 3. So we get negative 3 minus 3 equals 2 times the square root of 12 minus 3. Negative 6 equals 2 times the square root of 9. Negative 6 equals 2 times 3. Negative 6 equals 6. No, it doesn't. So it says now in the answer, the WebAssign, it says, let me show you what it says here. All right, so it says to put the smaller value and then the larger value. So negative 13 would be the smaller value. 3 would be the larger value, okay? Negative 13 is not extraneous because it does work. 3 is extraneous because when you plug it back in, it doesn't work. So here are your correct answers in the green and gold key rectangles. All righty. Any other questions about that particular problem? Okay, well, that's all that I got requested ahead of time. So do any of you have any questions you'd like me to look at? If so, now is the time.
Yes, for the chapter review, I totally forgot to email you about it, but it was number question 43.
Okay, hang on just a minute.
Okay. Sorry, I couldn't find my mute button. I was panicking.
Oh, no. Okay, let's see. Okay, must be in 4400. Go. You said the chapter review?
Yes.
Okay, chapter 9 review. And which one or ones?
Number 43, just that one.
43, okay. Okay, so 43. Again, this is from the chapter 9 review.
Yes.
Simplify the expression. All variables represent positive real numbers. I see already what happened. So you've got this, which is 15xy over 64a to the 4th. XY. All right. You could split that up into two separate radicals. In the numerator, there's nothing we can do. In the denominator, the square root of 64 is 8 on the outside. The square root of a to the 4th is a squared on the outside. Okay, this is the correct answer. Now, what you had was that, and maybe you meant to write it that way, maybe you didn't.
Oh, yeah, I see now.
Yeah, but you've got
That's probably why I was like, this is right. I don't know why I'm getting it wrong.
Yeah, so you've got to be
Okay.
careful that you distinguish between that this is not
two.
inside the radical. Yeah.
Okay, yeah.
Okay, anything else? You or anyone else?
That was it for me.
Okay. Danielle, Marcos, anybody?
Yeah, can you do number 17 on the chapter 9 review?
Okay, hang on. Let me find your stuff. And you said the chapter 9 review,
Yeah,
which one or ones?
just number 17.
17. Okay. So this again is from the chapter 9 review number 17. It says the total surface area of a cube. Let me make this bigger here. The total surface area of a cube is related to its volume V by the function A of V equals 6 times the cube root of V squared. Find the surface area of a cube with a volume of 27 cubic centimeters. So basically you want to find A of 27 because that was the given value. Okay, so that's 6 times the cube root of 27 squared. All right, now 27 squared is 27 times 27, which is 3 times 3 times 3 times 3 times 3 times 3, because this would be 27 and that would be 27, which is 3 to the 6th power. You okay with that?
Yeah, yeah.
All right. So then that's going to be 6 cube roots of 3 to the 6th power. The cube root of 3 to the 6th power would be 3 squared. So you get 6 times 9, which is 54. It's not square, it's cubic. Oh, no, it is squared. Oh, find the surface area, my bad. Okay. So there you have it. All righty.
Okay, that makes way more sense. I was getting that answer.
Sure, sure. Anything else? Anybody?
Could you maybe go over number 14 on 9.5?
All right. Okay. Danielle, what's your last name?
Rainy.
That's what okay, okay. I missed it. I thought that was you, but I didn't see it. So, there you are. Okay, sorry. You said 9.5?
Yes, please. I think I got it right the second time I did it. I just don't feel really comfortable
Sure.
in how I actually.
What question?
14, please.
14. Okay. Sorry it's taking me so long. You're gonna have to open things up and unopen them, whatever, close them. All right. So this is 9.5, number 14. Solve the equation, enter your answers as a comma separated list. And yes, you did get them correct, but let's take a look. So we've got the cube root of b cubed minus 63 equals b minus 3. So we have a radical that's a cube root. It's already isolated. because it's a cube root, we have to cube both sides. On the left side, I get b cubed minus 63. On the right side, it's good. Oh, I hope you brought your lunch with you, because this is b minus 3 times b minus 3 times b minus 3. So that's going to take a little bit here. So we're going to do the first two to start with, which is going to be what? B squared minus 3b plus 9, which is b squared minus 6b plus 9 times the final factor of b minus 3. So far, so good?
Yep.
All right. This is going to give us b cubed minus 3b squared minus 6b squared plus 18b plus 9b minus 27, which is b cubed minus 9b squared plus 27b minus 27. So I'm going to subtract b cubed from both sides, which now gives me negative 63 equals negative 9b squared plus 27b minus 27. I'm going to go ahead and add 63 to both sides, which gives me 0 equals negative 9b squared plus 27b plus, is that 36? Yeah. Now, I knew that I was going to have a negative coefficient, but I also knew I was going to be able to factor it out. So I'm going to factor out a negative 9, which is going to give me b squared minus 3b minus 4. Okay. So 0 equals negative 9 times b minus 4b plus 1. So b minus 4 equals 0, b plus 1 equals 0, add 4 to both sides, b equals 4, subtract 1 from both sides, b equals negative 1. All righty. Let me know when you're ready to go on, Danielle. I'm going to check our work here in a minute, but I'm going to go to the next page to do that.
I'm good here.
You're good. Okay. So we've got the cube root of b cubed minus 63 equals b minus 3. And we've got b equals 4, b equals negative 1. So if b equals 4, we get the cube root of 4 cubed minus 63 equals 4 minus 3. 4 cubed is 64, and 4 minus 3 is 1. 64 minus 63 is 1. The cube root of 1 is 1. 1 equals 1. It checks. Okay. If b is negative 1, the cube root of negative 1 cubed minus 64, minus 63 equals negative 1 minus 3. The cube root of negative 1 cubed, negative 1 times negative 1 times negative 1 is negative 1. Negative 1 minus 3 is negative 4. Negative 1 minus 63 is negative 64. The cube root of negative 64 is negative 4. Negative 4 equals negative 4. Check, check, check. Okay.
Thank you.
Yeah.
I realized I forgot to flip the symbols when I pulled out that negative 9 the first time I did it. So I couldn't figure out where I'd gone wrong and how I got it right the next time I did it. So we're good. Thank you.
The difference is when I make mistakes, it's in front of everyone. You get to do it in private.
Super secret mistakes over here.
All right. Anything else? Anybody? Well, all righty. So we've got what? We've got solving systems of equations by graphing, solving them by, no, wait a minute. That's the Math 85 class. My bad. We've got dealing with radical equations, checking your work, extraneous solutions, let's see, exponent, fractions as exponents. You've got those rules of exponents, lots of stuff there. All right, I will be back this afternoon at 1:15 should you have need of me. Otherwise, again, there will be no regular class scheduled tomorrow. Just take your test. I will be back tomorrow afternoon for an office hour, but anyway, and I'll be back today at 1:15. So we'll stop the recording